So hello everyone. Today we are going to talk about isoenzymes. So first thing, what are isoenzymes? So it is a different form of an enzyme. Okay, different form of an enzyme catalyzing same reaction. All right. So the form is different, but the reaction which it catalyzes is same. Now, how they are formed? Okay. So to remember this, how they are formed, we need to know our mnemonics. So true lady, let it be somewhere. True lady is allowed. All right. So true means true isoenzymes. All right. So it means these enzymes are originated from different gene. All right, and might be from different chromosome. So this is optional. It can be from different chromosome or it can be from the same chromosome, but the genes are different. All right. So now, what is the example of true isoenzyme? So amylase is one of the example of true amylase, true isoenzyme. So one is found in saliva, so salivary, and another is found in pancreatis. So it is pancreatic. All right. So this is the true isoenzymes from which is from different gene. All right. So for lady is for lactate dehydrogenase. Okay. So this is found by the random accumulation of two different polypeptide chains. So this is of five types. One, two, three, four, and five. And these all five types are found in every individual in any part of the world. All right. So this is lactate dehydrogenase. Now isoforms. Okay. So isoforms are post-transcriptional modification. All right. So this is modified after the transcription. Then after there is enzymes. All right. So enzymes are from different alleles. All right. An example of this is G6PD, glucose 6 phosphatase. All right. And there are around 400 types of it. And each individual has only a single type. So this one is every type of is found in this. Then after in this XPD, one in each person. Now, okay, so isoforms. So for isoforms, you need to know the creatine kinase. So it is found in 1, 2, and 3 types. All right. Now we have learned how they are formed. All right. So these are different processes by which they are formed. Now, what are their characteristics? So first thing, electrophoretic mobility. So we have taken one example, lactate dehydrogenase. All right, it has 5 forms: 1, 2, 3, 4, 5. All right. So this lactate dehydrogenase 1 is fastest, and 5 is slowest. So in this basis and by sequence wise. So in this way, lactate dehydrogenase is divided based on electrophoretic mobility. Then there is a stability to heat. All right. So for this there is one example, alpha 2HL. What is this? So this is the one of the form of lactate dehydrogenase. All right. So this one is heat level, as it is sensitive to heat. Now, so first characteristic is electrophoretic mobility, second one is stability to heat, third one is inhibitors. All right. So some are tartrate labile. And one more thing, uh, so tartrate labile acid phosphatase. So one is labile to tartrate and another form is not labile. All right. So this is one more characteristic. Then after, so one inhibited, another is not inhibited by it. Then after there is cofactors. All right. So in cofactor, the enzyme is same, but different cofactor is required to for functioning of it in different places. For example, there is one enzyme isocitrate dehydrogenase. All right. What is the name? Isocitrate dehydrogenase. So in mitochondria, to function it needs NAD. All right. So this form is required to function in the mitochondria, but in cytosolic form it requires NADP to function. So in different place different cofactor is required to for functioning of this enzyme, which is isocitrate dehydrogenase. All right. Then after, sensitivity to antibody. All right. So some are sensitive, some are insensitive. So this is one of the basis of um, so this is one of the characteristic of isoenzyme. Then after, one more characteristic, that is tissue of origin. All right. Tissue of origin. So some are originated from bone, some are originated from liver, some are originated from intestine, some are originated from biliary, some are originated from uh, placenta, some are originated from leukocyte, alkaline phosphate. So these are different ALP forms which are found in different places. All right. So now something, one more thing. Yes, these are six and one more, that is seventh. And seventh is Km and affinity. So first thing, if you have studied, Km is Michaelis constant. All right. And what it shows? It shows substrate concentration. All right. Substrate concentration for which uh, rate of reaction is half of maximum velocity. All right. So this is showing for what concentration of substrate the velocity of the reaction will be half of the maximum velocity which can be achieved. So this is one thing. So Km of different enzyme is less and more. All right. And affinity of enzyme also less and more based on different isoenzyme form. So these are the characteristic of isoenzyme. Now we need to see some isoenzymes and their significance in clinical. All right. So let's talk about first isoenzyme, that is lactate dehydrogenase. All right. So I've already told you it has 5 forms: 1, 2, 3, 4, and 5. All right. So its naming is very simple, starting from H4 and it goes to M4. All right. So H3, now M. Now reduce H3 by 1, so H2, and increase M by 1, so M2. Now one more thing, now H1 and sorry, you don't need to write M1, H and M3, and lastly M4. All right, so H4 is found in heart, so very simple, H4 and heart. Then after there is M4 is for muscle, so completely M, so muscle. Now M3 is found in liver. All right, so these are the things which you need to know. Now one more thing, generally this lactate dehydrogenase 1 is less in our body, and MH3M is more, that is around 35%. All right, but in case of myocardial problem or heart related disease, what happens, the content just flip, H1 increases and H2, sorry, I'm so sorry, LDH1 type 1 increases and type 2 decreases. Currently type in normal individual, type 2 is more, but in the person who has heart attack or heart related problem, the H4 will be increased more than H2, sorry, S3M. All right, so I hope I could make this clear. I'm sorry. Now one more thing, see, LDH1 increases in 6 to 12 hours. So we can find the LDH level of type 1 is increased in 6 to 12 hours. So in 24 to 48 hours, it's in its peak concentration, and you can find its elevation up to 6 to 10 days. All right. So this is a lifetime of this LDH enzyme in different heart condition. So this is only for heart, and this is one of the main enzyme for the diagnosis of myocardial infarction. Then after there was creatine kinase. All right. So for creatine kinase we have three forms: CK1, CK2, and CK3. So start from B. So BB, then after BM and MM. So BB is found in brain, and BM is found in heart, and MM is found in muscle. So we need to see this BM. All right. So I'm so sorry, MB. All right. This need to be written as MB. So let's focus on MB. So this is the first enzyme to increase, all right, in myocardial infarction. So after 3 to 6 hours, you can find CKMB has increased, all right, and it's in peak concentration at 12 to 18 hours, all right. So it's a peak condition. Then after 36 to 48 hour is its lifetime. That can be said as 1.5 to 2 days. Then after we have next enzyme, that is alkaline phosphate, ALP. All right. So this is the last enzyme we are going to talk about. So it has different forms. Let's talk about each one. Alpha 1, alpha 2HL, then after alpha 2HS, and then after pre-B, and then after gamma, and then after LAP. So these are different form of ALP. So there are 1, 2, 3, 4, 5, and 6. So there are 6 type of ALP. All right. So first one, A1 is found in biliary tree. All right, and it is about 10% of the total concentration. Then after AH2HL, L is for liver, so it is found in liver. HSS, placenta, so it is found in placenta, so it is placental ALP. All right, and pre-B is for bone, and it is around 50% in general. Then after gamma is found in intestine. All right, and then after LAP is found in leukocyte. So now ALP in hepatitis, all right, increases by 2 to 3 times. If there is condition of hepatitis, the level of ALP will be increased by 2 to 3 times. and which one? Liver A2L1, A2HL will be increased. Then after different obstructive diseases, all right, obstructive, for example, cholecystitis, all right. So in cholecystitis the biliary duct is closed, so now bilia will be found sorry, so now the ALP will be increased about 12x to, sorry, 10x to 12x, 10x to 12x. So 10 to 12 times the ALP level will be increased in obstructive cholecystitis, all right. So this is all. Now a few more terms. There are Reagan isoenzyme. So this is placental and also placental variant, all right, and it is increased in carcinoma of lung, liver, and gut. So Reagan isoenzyme is increased in um, carcinoma of lung, liver, and gut. Then after there is one more enzyme, that is Kasahara isoenzyme, all right, and this is fetal variant, and this increases in uh, okay, so this is fetal basic variant of isoenzyme. I think it's increases in tumor, so I can't currently recall it. You can find it, but maximum chance it is increased in tumor, all right. Now there is Nagao isoenzyme, all right, and this is germ cell variant of ALP, all right. So this is all from my side. I hope I could make the isoenzymes clear. And how do we use it clinically? You can just think, for example, if there is myocardial infarction, CKMB level will be increased, and then after we have already also seen this uh, in lactate dehydrogenase form, the S3M level will be just flipped with S4. Means current in initial condition S3M level is more, but in myocardial infarction or heart related problem, H4 level will be increased more than LDH type 2, all right. And then after there are the characteristics of enzyme which is required for different places of our body. So I hope I could make these things clear. If you want this note, you can visit you can visit omnimedico.com, omnimedico.com, all right. So you can find this note over there. So I hope I could make the things clear. Thank you.